Hello everyone. So today we are going to see the problem of GFG POD, and the problem is remove half nodes. Here we are given binary tree and we have to remove all the half nodes which are having only one child, and after that we have to return the modified tree. So here if we see the example, here we can see 7 is only a node which is having only one child. So 7 we will remove, and we will return the in order traversal of the resultant tree. So 2, 5 and 8. Okay, so here will be the intuition. So here we are given 5, 7, 8 and then 2. So we have to remove all the nodes which are having only one child. So 7 is the node we having only one child, so we have to remove this, and we have to remove its child to its parent. So after removal of 7, it will look like this. Okay, so if we go with another, so here we have to find out the nodes which are having single child. So this is the node which is having single child, this is the node which is having single child, and then 3 is also having single child, and then 7 is also having single child. We have not to remove the child which are leaf node. Okay, so here we are removing these nodes which are having only one child. So how we can do this? So firstly we will go to the left, then right, and we'll check whether it's left and right. Left and right both are not null. If both are not null or both are null, then we will return the root value. Otherwise we will return the its child value. So here when it is let's suppose we have come to the left part. So here we got null. So null, if we are getting null, then it will just return a null. If here we come, then we will check for the right one. So right node is containing its null, it is the leaf node, so it will just return as it is. So it is returning the 8 root node, and then 4 is having its left child as null, its right child as not null. So 4 will return the not null child to its parent. So 4 will return, 4 will return, 4 will return 8 node. It will return its right child. Now 2 will check, 2 has checked its left subtree. Now it will check right subtree. Right subtree is null, so it is the node which is to be removed. So it will return what value it get from its child node. It got 8, so 2 will return 8 from here, right? So 8 returned to 1, so 1 will append 8 here, because its left child 2 was also having a only one child, and it 2 is having 4, and 4 is also having only one child. That's why these two nodes got removed, and 8 will be the left child of 1. Then it will 1 will check for the right one. So right in when it is going to check the right, then it is firstly going to the left, then right. So now we are at 9. 9 is the null, 9 is the leaf node, so 9 will return its own value. 10 will return its own value because these are the leaf nodes. 6 is having both nodes as not null, so 6 will return its own value. So 5 will get 6 as its value from left subtree. So 5 will add 6 in its left subtree, and the whole subtree will get retained in its left subtree. And then 5 will check for the right one. So 7 will go and check. So it's having null node and it's having not null. So both the left child is null and right child is not null. So 7 will not return its own value. Instead it will return its not null child. So not null child returned from here. So 5 will append 11 here. 5 will append 11 here, and then 5 will have both value as not null. So both value as not null, so 5 will return its own value. 5 will return its own value. Now 3 is having its left as not 3 is having its left child as null, but its right child is not null. So not null child will be returned from here to its parent. So 3 will return not null child. So not null child is 5. So 5 will get returned from 3, and 5 is holding the value of 6, and 6 is holding the value of 9, 10, and here 5 is having its right child as 11. So this is how the intuition will work. And let's code it out. So here we will take solve function, and inside that we will pass the root, and we will return this solve function. So here our solve function will return always the node, and it will take the parameter as node inside it. So this is how the code will work. Whatever the solution I have mentioned in the intuition, the same is applied here. We are just returning null, and then we are calling for left subtree and the right subtree, and then we will give the value of left to the value we have got from the solve function in the left, and we will give the value to the right of the current node as we got from the solve function of subtree, right subtree, and then we will check which node is not null. That will get returned if our root is not having any node as null, or having both node as null, then root will get returned. So let's compile it and run it. Okay, so let's submit it. Okay, so now let's go for the complexity here. We can see we are traversing in each and every node here. So the time complexity will be big O of n, and we are traversing in the maximum to the height when we are doing the DFS searching, like we are going till the left, then we are going to right, then maximum the auxiliary space can be height of the binary tree. So here expected time complexity and space complexity is matching with our solutions complexity. So this is how the solution will work, and the intuition came for the solution. I hope this was helpful to you. Thank you.